Guys and girls, it's Know It time!
So guys and gals, today I'm going to continue on what you did the other day, and it was Trig Proofs Part 2. Guys and gals, it's Know It time! Your favorite time of the day. And it's also your last block of the day.
Till spring break.
2 weeks off.
So what are you going to do during spring break?
Go to China.
China. No. There's your picture so far.
Do something out of the norm.
No, that's it. So here's your lesson. Now, I've taught you basic trig identities. For example, I've taught you 10. And I told you that awesome joke, except none of you got it. Sin x over cos x.
The tan one?
Yep.
I got it.
It was very funny. Yes,
No,
yes.
it wasn't funny though. I got it.
Cotangent x. Because the key to doing trig, remember, convert everything to sine and cos. If you did it right, everything will follow nicely. If you did it wrong, you're going to make a mistake somewhere. Secant. Sorry?
Are you going on the quiz right now?
No, I'm not going over the quiz. I'm just going over the basic rules. Cosecant. Because I told you that when you started Math 12, there's 22 formulas you got to memorize. These are some of them. Sin x. Voila. Now, today I'm going to teach you one more key formula. This is going to be the most important formula for this chapter. Put a star beside this formula. Sine squared x plus cos squared x equals to 1. Oh, there is a joke. How do you know there's a joke behind this? Oh, really? Is my joke that famous? It's not really a joke. It's a really, really powerful equation. You can actually apply it to real life. And there's a story behind this. So sine squared x plus cos squared x equals to 1. And the story behind this is this. A couple of years ago, my friends and I were downtown. We were eating at Earl's, and downtown is known for their very, very well-dressed people. And there's a waitress there. So this waitress, she's... So this waitress, she's all, pretty up and everything. And then when the bill came, I was trying to impress the waitress. And so I told my friends, no, I got this. And then I was talking to the waitress. And I said, hey, baby. No, I didn't use the word baby. Okay? I'm like, hey, how you doing, right? And I use one pickup line so powerful, it's guaranteed to get you any number you want. Guaranteed. Works flawlessly. So I went up to her, and I said, hey, did you know that if you're sine squared x, and I was cos squared x, together we'd be? 1.
Did she walk away?
No. Let's just say now, see, if you were to use this on another math student.
After that is beyond PG-13.
Yeah, well, when you're university, we'll tell you what happened after that. So if it's to use this on another math student who had taken math, they're like, oh my god, that's the best pickup line I ever heard in my life. If you're so all it is if you're sine squared x, and I was cos squared x, together we be 1.
That's the line that mathematician genius guy probably used on his wife.
Yeah, it works really, really well. And I actually had a student from last year. He actually used this line to get his girlfriend. Could you not? And both of them were in my Math 12 class. And the first time he used it, I can't tell you who, because you. I can't tell you who. And it works. Let's just say that it works, guys. So next time you go home tonight.
They were the only 2 smart people that were in his class that are dating.
So you can turn to the person behind you or in front of you and just say, hey, if you're sine squared x, who never know.
What if there's a guy beside you? That'd be awkward.
Hey, I'm open-minded, So guys, that's how you remember the formula. Sine squared x plus cos squared x equals to 1. It's one of the most powerful formula there is. The reason why a lot of people forget this formula. Now, I can modify this formula in a couple ways. For example, I can rewrite this as sine squared x equals to 1 minus cos squared x. So a couple years ago, we went to Earl's downtown, and we actually had students try this. So Amrit, I don't know if you guys know Amrit or not. He actually went downtown, and he actually used this line, try to pick up the line on the waitress. And what happened after that, we'll tell you later. Oh, no. Let's just say he was all smiles.
Whoa!
No, I'm kidding. Sine squared x equals to 1 minus cos squared x. Because all I did was I moved the cos squared x over to the right side. If you see cos squared x, you can rewrite it as 1 minus sine squared x. Okay? I'm just playing around with the equation. You got to learn how to manipulate this left and right, and it all came from one formula.
But you know, when do you know when you have to like change it? Like when do you have to like?
You just do. Trust me. I'll give you a question. I'm gonna give you a question, and I'm gonna see how you can do this. Good luck. Bum-ba-da-da-dum. Oh no, you're not ready for that yet. Try this one. So I'm gonna write a few things down. Star. If you see sine squared or cos squared theta, there is a good chance you will need to use this formula. There is a good chance. I'm not telling you it's a guarantee. I'm saying there's a good chance you will need it. So guys, when you go on spring break, try this for pickup line. See how many phone numbers you get. See if it works. You will need the formula.
The girls probably got thrown the ice cream on my face.
No, they say, here's my number.
You should know when we can get it. Yeah.
You gotta try it on someone who has taken math well before. Now, if I were to use this on an English teacher, so if I was to use this on, like, say, an English, or try this. So I want you to prove. Again, the key is gotta be able to do the setup properly. Whew, this looks challenging. Sine x plus cotangent x cos x equals to cosecant x. I'm gonna pause it and let you try. Oh, you almost got it?
I got it.
Okay, first thing, I'm going to convert everything to sines and cos. Now, I see both sides have things that are not sine and cos. For example, cotangent and cosecant. I know I have to work with both sides, so I'm going to work with the right side first. 1 over sine x. Somehow, my left side has to be exactly like that. Sine x plus cos. Now I'm too lazy to write x, so I'm just going to write down short form. Cos. Okay. I can rewrite this as sine plus cos squared over sine. Agree? Guys, I'm going to pause it right here and see how you can figure out what. So I'm going to use a common denominator, which is sine. If I do common denominator, I get sine squared over sine plus cos squared over sine. I can merge these two fractions together now because they're the same denominator. Sine squared plus cos squared over sine. Somehow, I'm not done yet. I'm too lazy. I will in the end, but really I want to save a bit of time. 1 over sine x. And look at my right side. 1 over sine x. Hey, left side equals the right side. Yeah. Because sine squared, remember, if you were sine squared, just think back to my Earls star. Earls. What did I do at Earls? If you were sine squared and I was cos squared x together, we'd be 1 for life. For life, remember that, guys. So if somebody proposes you and say, hey, if you were sine squared x.
How many times have you used it?
How many times? I try not to use it too many times because I don't want too many numbers. only use it when it's appropriate. So guys, is this a really, really powerful formula? Should use it. Try it. Spring break, that's your homework. Try it on a random person. Walk around downtown and say, oh, please. One more, and I'm going to move on to the next one. 1 minus secant squared x equals to negative tan squared x. I'm going to pause it right here, and let's see how many only. So first thing, I always draw a line. The reason why, I want to see what's the left side, what's the right side. If there's no line, it's too hard to follow. I will take marks off if you don't have the middle line right here. I repeat, marks will be taken off if you don't have this middle line. This side, I can rewrite this as negative sine squared x over cos squared x. Very simple, no tricks. My left side, I can rewrite this as 1 minus 1 over cos squared x. Okay. Common denominator is cos squared x. So I can rewrite this as cos squared x over cos squared x minus 1 over cos squared x. Okay. Denominators are the same, so merge. Again, nothing too bad. I keep it simple. Cos squared x minus 1 over cos squared x. The problem is, if I look at this, a lot of you say, Mr. No, that's not a trig identity. Because the trig identity, there's 3 of them I taught you. This was, one was cos, I just do cos squared plus sine squared equals to 1. 1 minus sine squared equals to cos squared. And the other one was 1 minus cos squared equals to sine squared. Okay. Now, if I look at this and say, hey, Mr. No, doesn't this and this look identical to each other? The answer is no. The reason why I look at this is a negative 1. This is a positive 1. This is a positive cos. This is... So all they did was they multiply. So they did was they used a negative form of this, which is, if you use a negative form of this, this becomes negative sine squared x. That's one of the few tricks you got to work with. Over cos squared x. See why? Because this form and this form are really negatives of each other. So all they did was use a negative form. One formula, they can manipulate it many, many different ways. And all it is just how well can you work formula. Aaron, question? Ah, good point. Says, hey, if you were to work with this, right? Aaron says, Mr. No, can't I just do this? Negative sine squared equals to 1 minus cos squared, right? Over sine squared.
Cos squared.
Nope, sorry, cos squared. It would be exactly the same as the other side too. Yes, you could.
So we could stop it right there.
Yeah, well, up to you. Makes no difference to me. I just want to have a basic understanding that you can get up to here or there. That's it. So you can either work with the right side or you work with the left side. Many ways of attacking this problem. Guys, gals, question? No. Nope. Negative stays the way it is. No, it says it can't. You can't move anything. Now I'm going to give you questions where it's go work with something called hardcore fractions. Hardcore fractions. You have to be able to work with fractions because a lot of people are weak on fractions. Again, the key to working with fractions is separate top and bottom. That's the key. A lot of people don't do that. They try to be a hero and they get themselves into a lot of trouble. Good luck with this one. 1 plus 10x over 1 plus cotangent x equals to 10x.
What does that say?
Hardcore. I couldn't come up with a better name, so I came up with that name. Guys, gals, I'm going to pause it. Let you work out on your own. So first thing I'm going to do is just write down this vertical line. Keep it simple. I'm going to work with 1 plus sine over cos over 1 plus cos over sine. This right away looks very complex. Okay. So instead of doing all this in one shot, I'm going to write down top, which is I'm only going to work with the top. Forget the bottom for now. And the top is 1 plus sine over cos. This becomes cos plus sine over cos. I did a common denominator. I skipped about 2 steps, but you should be able to follow along. The bottom part, see? I always write it separately, because if you do, it makes your life a lot simpler. Bottom, 1 plus cos over sine. Common denominator and to simplify. This becomes sine plus cos over sine. Guys, gals, there's my new top. There's my new bottom. Put it on top of each other and finish this question on your own. So now I get cos plus sine over cos all over sine plus cos over sine. Question? Oh, okay, now I'm going to pause it. Last step, just multiply by the reciprocal. And if you multiply by the reciprocal, you should get cos plus sine over cos times sine over sine plus cos. Hey, these cancels out, both of them. And you're left with sine over cos, which is the same as the right side. Sine over cos, LS equals to RS.
Do you only write LS?
Here. And then spring, no. And then you have 20 minutes and then spring break. Oh, yeah. 20 minutes of quality time with me before you go for 2 months, 2 weeks. Huh. Somewhere you're not invited, Grumpy. Your question will be cos x minus cosecant x over sine x minus secant x equals to cotangent x. Full work. Proper setup. If your setup is not proper, I will not even look at it. I'm looking for a proper setup. You got to learn how to set up this question properly. I'm going to pause it. So, here we go. I'm going to show you a lot of common mistakes I saw and where people made errors. So, please watch up here so you don't make the same. So, I go cos minus 1 over sine minus 1 over cos. I see a bunch of fractions. I'm going to make it... Yep, no problem. I'm going to make it top and bottom. That's the key. I'm going to write down top. Top is going to be cos sine minus 1 over sine. I did a lot of simplifications. Now, your bottom will be, so which is sine minus 1 over cos, which really becomes sine cos minus 1 over cos. I'm going to put top over bottom. And here's where some of you are starting to make errors. I'm going to show you where. A lot of you are making errors. The first mistake I saw, you can say, hey, Mr. No, I'm going to cross out this cos with this cos. You can't do that because there's to be connected to the minus 1. You got to leave it the way it is. So this becomes cos sine minus 1 over sine over sine cos minus 1 over cos. Multiply by the reciprocal. Some of you even got up to here. And here's what you get. Cos sine minus 1 over sine times cos over sine cos minus 1. Some of you multiply straight across. That's your error. Right off the bat, I can see things I can cancel it right away. All this is gone. It cancels out with all of this very nicely. And you're just left with... So the key step, I know if you got it right, it really is this step that's looking for right here. This was the key step. If I saw this on your paper, I know you did it right. And that's how I knew if you got this question right or wrong. So you have cos over sine. And the right side will be just cos over sine ls equals to rs. Voila. Okay. That's one step. I know if you got it right or wrong just by crossing this out. Your work. That's it for today, guys. Page. So you have 2 weeks to complete this assignment. There's a quiz when you come back. So make sure you practice. Just on this stuff. That's it.
The quiz on the day we get back?
What?
Quiz on the day we get back?
No. The quiz when you get back. Yes. Page.
But the day we get back?
The day you get back. Yep. Page 87. Numero 21 to 30.
When's our test?
That's it. Yeah, right. So 9 questions. Please.
Wait, that's it?
No, I say yeah, right.
When's our test?
Your test is the first week after spring break when you get back.
So we should start studying.
You should start studying soon because your test will be proofs and multiple solutions. That's the key, and exact values. Page, it is all written. I repeat, all written. You got to know your stuff. There's no guessing and testing. And numero 1 to 10. So really, it's only 19 questions for work.
Are we learning new stuff after the break? Like,
Yeah, you are. Well, we are not done yet. Proofs, there's going to be about... I need about 2 more lessons with you on proofs. And then we're going to do review. And probably review, and then your test will be on a Friday. If my calculation is correct. Hoping that there's no more strike.
Are there going to be weekend math challenges?
Weekend math challenge?